Today's video is about this box over here, and what it is a ExpressVu satellite TV HD receiver that I bought, I'm thinking probably close to 20 years ago, and it is actually a perfectly working box. The unfortunate thing is it doesn't have any satellites to connect to, and that's because about maybe 10 years ago, Bell decided to change the transmission standard of their HD signals from MPEG-2 to MPEG-4, and in doing so, obsoleted all these MPEG-2 receivers. Now, what they did was they actually sent out new ones free, and it's kind of an interesting calculation. Because if you think about it, a satellite like that probably costs 300 million bucks and another 100 million to launch it. And if Bell has perhaps 1 million customers at the time for satellite TV, I've looked today and the number is somewhere between 1 and 3 million. If they have, say, 1 million, just to make the numbers easy, and they were to send out these receivers, which maybe cost 150 bucks a piece, perhaps, it would cost them 150 million bucks to equip everybody with a new receiver, whereas putting up a bigger satellite would probably cost close to $500 million. So that would actually be a good benefit for them. And in fact, they probably had nowhere near 1 million people with these receivers, maybe 100,000. So it probably only cost them, say, 15, 20 million bucks to do the upgrade. And of course, the payoff for them was using MPEG-4 compression. What they could do is put more channels on the satellite and make more money. Anyway, with that in mind, I thought it would be a good idea to take this thing apart and look what's inside it. I'd actually been keeping it because it does have a regular TV signal, in other words, from an antenna input, and it apparently can tune standard high-def signals that are over the air that are not satellite. And I was sort of keeping it because I thought, well, an over-the-air tuner might be useful. The unfortunate thing is, it turns out it will not give you access to the terrestrial over-the-air HD signals unless it detects a signal from the satellite. You don't actually need a subscription, apparently, but the bottom line is you need it hooked up to a pointed dish, and although I have that, that's really too much of a nuisance. It does actually work perfectly. I'll plug it in. It'll take a minute or so to boot up, and we should see it on the screen over here. It always takes longer when you're watching. Ah, there's something. And there you go. It's desperately trying to find a satellite, but because I've got nothing connected to, that's going to be a rather futile search. One of these buttons here will give us a menu, and we can sort of do all sorts of things, including things like the system setup, where if we hit installation, we can see the strength of the satellite signal, which of course right now is 0. So sadly, it is a completely working piece of electronics, but it has become obsolete. And since I can't practically use it for terrestrial TV pickup, the best thing to do is to take it apart and see what's inside and get some use out of it that way. It looks like, to take it apart, the top part of the receiver comes off, and to do that, what we have to do is unscrew these screws on the side. So let's do that real quick. There's number 2. It will be quite interesting to see what essentially 20-year-old technology is going to look like. I mean, just from an appearance standpoint, it's interesting that it's a silvery color, because home electronic devices like this seem to toggle back and forth between being sort of a black color and a silver color. I think at times silver was meant to depict that it was slightly higher end, but it's probably just more of a fashion thing. And oh, there are a couple more on the back to take off. That's why it wouldn't just slide off. 1, 2. And here's the last. Now it should really come up and we should get a look inside. Yes. All right. And what do we have here? Well, so there's clearly two parts to it. There is a power supply section over here, and it is a switching power supply, and you can tell that because of the size of this transformer. And the rest of it really is the signal processing board over here. We have a little module attached to the remote antenna jack here. And what the remote antenna is, it's an RF input that you can use to control it using a RF equipped remote control. There's also somewhere under this black an IR input for remote control, and you could get two types. Anyway, what else can we see here? Interestingly enough, the input from the TV aerial goes into this aluminum box, and my guess is in this box you essentially have the entire TV receiver tuner and front end spitting an output into the rest of the circuit board. And it would be really interesting to know whether it's actually spitting out demodulated signal or whether it's just sort of spitting out the digital bit stream from the ATSC terrestrial TV signal. What else do we have here? In spite of the nice big power supply, there is what looks like a linear power supply here for some components, and these two items here are inductors of some kind, and could very well be that there's another couple of switching power supplies around here, presumably to provide perhaps a lower voltage like 1 volt or something for some of these particular integrated circuits. And oh, and one more power supply over here. What else do we have? We have a couple of giant ICs, and we'll zoom in on that one and see if we can make heads or tails of it. And we've also got this one over here, and we'll zoom in on that and see if we can tell what it is too. What else can we do here? Well, I'm going to take a look if we can make heads or tails of the output of the power supply, because it's certainly marked here. And I might even keep the power supply because it might be something that I can use for some other project. And I guess to further take it apart, what we're going to need to do is unscrew these connectors here and these various screws so we can slide out this main board. Oh, and here is our card reader. So we have to take the card out to be able to lift this board out. So here's the little module that is the receiver for the RF remote control, and it has some little IC on it. I'm going to just use an old magnifying glass to see if we can read it a bit better. We'll take a look at that afterwards. Is that ever a low-tech way of looking at it. But yeah, that's it. And then over here, this is the ATSC terrestrial high-def television receiver, and we should be able to zoom in and see who made it, and we'll look them up. The other thing worth looking at is, here is our satellite signal input from the dish, and right immediately on the other side, it's all within a metal can, presumably for shielding. Well, definitely for shielding, possibly to keep out external signals, but also possibly to keep the satellite signals in, because they could be of sufficient strength, because there is an amplifier in the actual feed horn of the dish. They could be of sufficient strength to interfere with other things. So this little box here could actually be to prevent RF flow both in and out. So if we look at the output of the power supply, which I've just zoomed into, we see quite an interesting array of voltages that you don't normally see. Certainly 2 rails dedicated to 5 volts DC over here, which is a good indication that there's going to be a lot of current drawn from them. And that makes sense, because 5 volt DC is a very common voltage these days, although it's often now, 20 years later, reverting to 3.3 volts. Oddly enough, there is a minus 5 volt on the other side over here, and you don't see that very often anymore, so I'm not sure what they'd be using that for. More strangely, there is 7 volts DC and 17 volts DC. My guess is they are voltages that are sent to the dish, because I know the dish does require a voltage to run the low noise amplifier. It's actually a block converter in the dish, and they do use 2 different voltages to do things like select polarization and or which of the 2 satellites you're going to receive signal from. So that 7 and 17 volts is probably for the dish itself, and then at the side there is of course a more conventional 24 volts that may in fact be being used for other things, such as driving some of the power supplies in the main circuit board. Okay, well, with all of that said, let's see if we can take out the power supply. And the first thing we have to do is disconnect it, which I did. And there are a couple of screws to undo, and maybe I'll just move it right in the middle so you can see it a bit better. That's one screw. And there's another screw over here at the top. And it looks pretty loose, although there's still something holding it in. And I don't, here we go. So there were a couple of tabs on this wall that were holding it in. And and there's one more little plastic tab sticking up. It's also holding the circuit board down. And out comes the power supply circuit board. And just looking at it, looks like it's a 2-layer board. It is actually quite common to have the power supply as a separate circuit board from the rest of the stuff, usually because the board may only be 2 layers, and often because they can actually be purchased from a company that does nothing other than make power supplies. One interesting thing you can see, and I'm going to just zoom in by pressing the zoom in button, is over here on the circuit board. In this, what looks like large ground plane, there is a very narrow cut in it. And if you're not familiar with power supplies, that might look a little bit weird, because why would you not just connect the ground plane together? After all, it's connected here. And you do that because in parts of the high voltage power supply, there can be very large circulating currents. And if you allow them to just flow anywhere, those large circulating currents can do things like introduce very small but noticeable voltage differences that can add noise to the whole system. And one way to prevent that is, if, for instance, you've got a lot of circulating currents here, you just put a little break in the copper plating to make sure that those currents don't spew out and affect these other components. Yet there's still plenty of copper for, let's say, the DC ground output to flow nicely around there. So that's rather interesting. What else does it say? It says designed in the United States, 2003. Okay, so that does give us a date when this thing would have been made. And as I thought, it was about 20 years ago. What else do we have? We have some PC board numbers. We have a PC board number here, and we have a barcode here that probably helps in the manufacturing process. And what else? Well, we maybe should just take the thing completely out, and to do that I need to remove this ground connection. And it's kind of interesting, there's clearly a large, probably toroid type filter thing right on the power cord to make sure no electrical noise gets out. I'm going to actually just leave the power cord attached, but I'm going to go get a pair of pliers to remove this connector right here. Alright, so we should be able to get this grommet type thing out if we're careful. These things are generally built to be put in but never removed, so it can be tricky. Can be very tricky. Since we're going to trash this, I'm actually just going to bend the metal like this to get it out. There we go. All right, so there you have it. There's the power supply. Just zoom out a bit. And yeah, I'm just going to keep that because it might be useful for some future project. And even if it's not useful for a future project, it does have some useful parts, namely all these capacitors, which are not worth taking off just to have them in a parts bin, but they can be useful to have around, because I've been in situations where on a long weekend I was trying to do some work and the power supply in a network switch I was using gave out, and I had to scour my box of old circuit boards for some replacement parts for the power supply, and I found some and was able to get the whole thing going again. So it can be useful to have stuff like that. Anything else worth noting here? A bunch of what look like metal oxide varistors here. That's what they probably are, I would think, to really keep spikes out of the system, which is really quite critical. You don't want spikes messing up your electronics. Maybe that's some sort of a choke coil. And this whole side of it, by the way, is high voltage DC, probably 150 to 250 volts DC, running a switching power supply with, that's probably the transistor doing all the business on the main switching, and into this transformer here, which then over this clearly marked barrier region goes over to the low voltage DC section. And yes, we can see there is really no connection on this side of the board at all. The only connection between these two sides is the transformer, and this would be an opto-isolator over here that allows the low voltage side to tell the high voltage side what type of a voltage exists here and whether we need to boost or reduce the amount of power we're sending across. So that is the power supply. All right, so now we have to undo these connectors so that we can try and lift out our main board. And interestingly, our remote control receiver device just comes completely out and disconnects here. So here it is. And anything to see on it other than perhaps looking up that integrated circuit? No. It does have a crystal on it, so it has its own oscillator, so it's probably a complete self-contained unit that they've gotten from some other supplier. It receives the signal and it sends out a digital bit stream, probably not unlike the digital bit stream you'd get from a light emitting diode style IR remote control receiver. And it probably just sends that bit stream to the same place on the main circuit board over here that the IR diode would be connected to. So anyway, that's out. The only other thing we have to do is remove a few more of these nuts, and I see a couple more screws, and we should be able to lift the thing right out. And oh yeah, here's one more of those coax connectors. It's interesting that they use the identical connectors everywhere. It's often good practice to use different connectors in different places so that users can't accidentally connect things the wrong way. For instance, perhaps for something like the remote control antenna connector, perhaps something like a BNC connector might have been a good idea. I suppose what the conclusion they had is the worst thing can happen if they've done their circuitry right is if you connect the cables the wrong way, it simply does not work, and they probably have a whole procedure set up for the telephone support people to guide the customers through the process when they said, I hooked up my receiver and it doesn't work. Okay, so I think we've got all our, one more screw to go. Then we will have all the screws taken out. And now I think there are, yes, there's one here, one on the main board, and there's some on the corners as well. And it's interesting, you have one on the main board right in, well, this area here. That's probably a shock thing, because when you start getting large boards like this, they can flex quite a bit, and that of course could produce stresses and cracks in the board. Now this might also be near where we have those holes underneath that we looked at, and it might be to hold the board nice and tight when the bottom of the board is probed during the manufacturing process. So Here's the screw at the corner, and then there's one over here. Oh, and the whole board's getting loose now, so I'm wondering if that's in fact it. That is it. So all we really need to do, oh, it's got a latch, not a latch, but it's got a thing holding it in down there, and I guess we have to pull up this set of connectors, and in theory we should be able to get it up. And of course, when you're doing something like this, you know that in the manufacturing process they've got some procedure set up so that it in fact just slides in very easily, so it can be produced quite quickly. So if we look at the bottom of our board, and again it goes in like this, so those probes that we had looked at would be here, and in fact here they are, and I'm just going to zoom in so we can take a look at that, because the zoom on the camera is not working very well. So it's actually a very odd type of connection right there. You have one really quite rounded connector. I shouldn't say connector, it almost looks like a blob of solder, and one square one, and clearly marked. So I've never ever seen a connection like that, and it does say something like, what is it, test point 76 right there. So somehow something probably sticks through the bottom of the box and connects to this during the manufacturing process and is able to do something like test and or load the software as needed. What else do we have? There's another thing that might just be a connection point. No, it's not a connection point. I think these are just markers of some kind. What do we see on top? They are right under the card reader. So yeah, these might, I'm not quite sure what they are. These might just be some sort of a manufacturing marker that you can put various indications perhaps of the different layers of the circuit board on it. And for that matter, I wonder how many layers this board is. It is quite a complex board, particularly if we look at some of these big ICs. I wouldn't be surprised if it's something like a 4-layer board. I guess the only other thing that would be of interest would be to, let's look at these two ICs. Broadcom. I'll bet you we can look up that one, and there's another one right near the satellite signal input, also by Broadcom. So we'll look at those and see if we can make heads or tails of them at all. Let's look inside some of these cans. So here's the can where the satellite signal goes in, and oh, there it is. And once again, it looks like there is a Broadcom chip inside. Can't really zoom in anymore, but the chip itself also has a crystal next to it, so it's probably doing some sort of initial down conversion of the signal. So that's interesting. We also have our somewhat larger terrestrial TV receiver box, and we'll see if we can open it at all. It may not be very cooperative. Yeah, I'm just going to go get a screwdriver. Maybe we can pry it apart and peek in. Okay, here goes nothing. So certainly didn't build this to be taken apart, that's for sure. And in fact, what it looks like, yeah, what they've done is they've actually soldered the corners on. So we might have to leave that for another day, although I can pull the other side off. And is there anything interesting there? Nope, there's just the back of a circuit board. So that's kind of disappointing. Let me just try one more time to see if I can, pry this apart. Yep, just pried it apart, and there. So that's probably the most interesting thing in the whole box. And we'll just zoom in a bit. And so what we can see is they very nicely compartmentalized the innards of the box into little shielded sections. Presumably the outer section over here is the initial filtering. I don't immediately see any active devices, but I wouldn't be surprised if hidden in here somewhere there's got to be a little transistor or two to do a preamplification of the input RF signal. And probably these coils are providing a very crude input filtering, and then after a certain amount of amplification, the whole thing goes to this section, which is probably the down converter. And very interestingly, the next section here has what looks like either a tuned transformer or a tuned coil that is very reminiscent of analog radios and TV sets. And what I'm actually wondering is whether this section might be a section to demodulate the old FM sound signal on an NTSC type video signal. And I don't know if we can read that IC's numbers very well, but maybe I'll have it go at it and just see what it is, and we'll also see if I can identify what this IC is. So the bottom line is, there you have it. That's the inside of a box like this. It's quite a sophisticated board, probably of the same order of magnitude as a PC motherboard type thing. And if you look at PC motherboards, they typically go for $100 or so. So you can imagine that this board in quantity wholesale is probably something in the neighborhood of that price. What I would expect is this whole receiver to, you know, on a wholesale cost basis, and you think that Bell is probably buying them by the hundreds of thousands, if not more, maybe $100, something like that, maybe $150, who knows for sure. I have at the back of my mind that this might have cost around $300 when I bought it way back then. And I know today the PVR type boxes typically cost $500, and I'll bet you if they even sell non-PVR ones, they're probably in the order of $200 to $300. So yeah, one would expect this thing to be $150 or so to Bell and sold to the customer for $300. And when you think about it, most people are probably paying $100 a month for satellite or cable TV. So $300 or even $500 for a receiver is actually a minimal cost. And usually companies like Bell will even rent you the receiver for $5 or $10 a month. So that's what's in it. The only thing that's really potentially useful is the power supply. And as I said, I'm just going to keep it, and you never know where it may come in useful. So that's the end of this video. See you next time.